Hi everybody, this is Nafish. In today's lecture, we're going to go over openCV, which is a computer vision framework, and this is open source. So basically, openCV is open source computer vision library, and this is vastly, we used it for image processing and machine learning, just to identify object from a picture, faces, handwritten digits, handwriting, all these things. There are many applications of this, but basically the major usage will be in the computer vision and machine learning domain. Okay, so this is the very first lecture. First of all, um, we need to install OpenCV, right, in our machine. So to do that, we need to do we can there are multiple ways, but since I'm in Jupyter Notebook, we're just going to write pip install and then OpenCV and then Python. Okay, if we run this one, since this is already installed in my machine, I think if you this will be a different result compared to what you have seen. So you see the requirement is already satisfied, so this is already installed. Or the second option, you can just go to the anaconda prompt, and basically you can just write down this pip install over there as well. Okay, so these are basically the two ways you can um, use it to install. Okay, so right now I'm just going to um, silent this comment. Okay, and let's so we need to since this is the very beginning kind of a lecture, we need a image to work on, and the image I can just get it from there. I will just show you the reference right here. um, this is in scikit-learn, so I'm just going to copy it and give you the link right here. Okay, so just go into the page, and then the very first image, go over there and save the image. Okay, so this is another machine learning toolkit, the scikit-learn. But today I'm just going to give you the link, and you can just go over by yourself if you have time. But just the reference of the image I'm going to use for this exercise. Okay, so let's first of all import OpenCV. So that is CV2 as CV. Okay, so this is the package, and we are just naming it as CV. Okay, so run this guy, and then um, we have to um, we have to open up the image, right? So the image we are going to be working on, so let's say I am read. We have to write down cv dot I am read. Okay, and then name of the image. So if you go to this home page, I already have that image, that is like this sample image right here. Okay, so I will just call that image sample image.png. Make sure like we have the extension as well, and we are keeping that image in a variable called kk. Okay, so we are reading this image using that imread function of opencv, and keeping the values in a variable called kk. Okay, let's run it, and let's visualize the image as well before we do anything. Okay, so cv dot imshow, and then we have to there are two arguments we have to provide: the name of the image, which will be in the display, let's say my image, and the values are from we are reading the image, right? So that is kk right here. And then another thing is like um, wait key. We have to provide a wait key. So wait key is let's say 0. I'm just going to go over this line in a bit, and then cv dot destroy destroy all windows. Okay, so basically what this is going to do, wait key, we are reading the data, and we are going to show the data through a GUID, right? So if we put 0 here, meaning it's going to display the image as long as I want, or press any other key, and I can destroy the image by myself. But if we put other values, and the values we have to remember that's in millisecond, then the image will be there for that many time, that long. Okay, so let's go over this first, and here we have our image. So we are reading that image. Let's go over it again. We are reading that image using this I am read, and then we are showing the image by I am show. Okay, and then the wait key 0, meaning the image will be here for as long as I want, as long as I do anything. So right now I'm just going to close it out, and then let's say uh, we want to have it for 1 second. So basically this unit is in millisecond, right? So 1 second, 1000 millisecond is 1 second. So let's run it, and you see the after that time the image is closing by yourself. Let's have it for 5 seconds, just for your curiosity. Okay, let's run it. It's going to stay there for 5 seconds. Okay, and close it by itself. Okay, but if we put 0, then it's going to be there forever. Okay, I think enough of this stuff. So we are able to read it, we are able to show the image by image show. One thing I didn't mention, like the default value right here is 1, which is like, color, meaning like the image is RGB or red, green, blue. Okay, it has color component. But if we put 0 here, then it's just going to be a grayscale or black and white image. Okay, let me show you. You see, it's black and white, there is no color. But if we put 1, then it is colorful. Okay, now let's save this image. Okay, so to do that, cv.im right, and then let's say give it a name. Let's say um, example image. Okay, the name of this image, and we need to provide an extension, so that is png, right? And then the value where from we are reading the image, that is kk. So let's save the image. Okay, true means it went through and run this command. Okay, and if we go to the home page and you see this example image right there, and you can see that image, it's saved in the same folder. Okay, so we have learned three things: how to read an image, how to display that image, and how to write or save that image. Now there are some other components or other part of the image at the very basic level we have to know. So we have stored the values of that image in kk, right? So let's go over that again. And you can see, just looking into these brackets right here, this is a three-dimensional matrix. Okay, so kk.endim, that will show you the dimension. This is 3. Okay, so it got 3 dimension, and I'm just going to show what are the dimensions we have. Okay, so kk dot shape, if we write down that one, so here it is. Um, so we have 480, 640, and 3. So this is the number of rows, number of columns, and this is the number of channels. Okay, let me write it down for you. Number of rows, number of columns, and then number of channels. So rows, columns, number of channels. So we have 3 channels, and then how many rows? 480 rows. Okay, so 480, and then how many columns? 640. Okay, so 640. Now we can understand the rows and columns, but the number of channel, this is nothing but RGB, red, green, blue. However, in openCV, the way we learn or read the data is BGR. So blue, green, and red. So the zeroth element will be blue. Okay, so the first channel is blue, is the first channel, and then the second channel is green. Okay, let's write it down. Second channel, and the third channel is red. Okay, so 3 channels: blue, green, and red. And then we have the number of rows and number of columns. Now the number of rows, if you just imagine, this is basically will give you the length of that image. Column is just the width of the image. There are a lot of other things, we'll just come into that later. Okay, so but this is, if we put kk.shape in this example, we can see the number of rows, number of columns, and number of channels. There are sometimes another component called transparency, and that's going to be a 4-dimensional in that case. Okay, this image is 3-dimensional. Okay, so what are the other things? Let's say kk dot size, and what is the size of this image? So this is the size. Okay, and how we are getting that size? This is nothing but, if we multiply all these 3 numbers, we're going to get this. Let me show you. So 480 rows, then 640 columns, and then 3 channels. So this is going to give you this many pixels in that image. Okay, so this is basically, some of the parameters. We can just, whenever we load an image, we can just go over this. Okay, now as I mentioned, like there are 3 channels: blue, green, and red. There is we can just read or split these channels. Okay, so there are 2 ways. So let's say kk, then you're taking all rows, you're taking all columns, and you are reading the first element, which is blue. Okay, so if you run this, so this is only the blue channel is providing. You can just change the value to 1, it's going to be the green channel, and you can change it to 2, that's going to be the red channel. Okay, so this is the way you can split the channels. There is another way to split the channel, which is we have to call cv dot split, and then um, we are going to split this kk variable and put all the data in B, G, and R. Okay, so basically BGR is cv.split. Okay, let's run it. So we have B, G, and R, and let me plot these values. Okay, so remember we displayed the image right here. Just going to copy these three lines, and rather than having the input KK, so let's have B here, which is blue. Okay, so let's have that and run it. And this is a single channel, and that's why you don't see any color there. You can have R as well, which is the second channel, all red, and run it down. You see a different image. Okay, so this is the way you can split, and that is another way you can split these channels. Okay, you can also merge this. Okay, so let's merge this BGR. Okay, so CV dot, rather than writing split, we'll write merge, and then B, G, and R, and let's have the name, let's say merged image. Okay, so this is where we're going to keep the values of this after merging. Okay, so let's run it, and let's display this. Okay, so we have to put this inside a bracket, all these three values. Okay, now run it, and then let's copy this displaying lines, and then rather this is going to be the name we are reading the data from. So, and then run it, and this should be a color image. Okay, and you see this is a color image, because right now we're merging all these blue, green, and red. Okay, so there are other ways to display the image as well, like using the matplotlib. So we can import that. Import, I think all of us are familiar with this matplotlib. So import matplotlib dot pyplot as plt, and then run it. Then plt dot I'm show. Okay, and then let's say we are going to display this merged image. Okay, and display this, and you can see like this image looks different, right? Remember here, let me play that again. When we are using this CV, the image was different, but here when we are using this matplotlib library, the image is different. Okay, and why is that? Because let me write it down so that you remember. In openCV, the color channels, the order of the color channels are B, G, and R. So blue, green, and red, as I mentioned before. But in matplotlib, this is RGB, which is, we are very much familiar with this order, right? RGB. So that's why, since they are like, when we are reading the data in OpenCV, that the format is BGR, but we are trying to, without any conversion, when we are trying to show that in Matplotlib, it comes in a different color. Okay, so we have to do a conversion. Okay, in this case, so let me do that. That is very easy. So it's CV dot, I think, let me write it down, color BGR to RGB. Okay, and let's run it out. This is not defined because I'm just not writing CV here. So now it should work. Okay, and let's keep it in a new variable called, let's say, KK rather than KK new name. Okay, and keep the variable the values there. Okay, and now we have to display it using matplotlib. So plt dot plot, and then KK new. Okay, so this is going over some issues there because I haven't written I am show. Okay, so right down there, and you see now we have gone back to the original color. So basically, if we do not do the conversion, then the color is going to be messed up. So we have to do the conversion if we are going to plot in the matplotlib library using that. Okay, and you can also do we can do many things in this matplotlib as well, but just going to show you a very easy example like plt dot color bar, and you see there will be some color bar popping up. So from this is the intensity. Okay, and basically you can also see like the the x-axis and y-axis right here. So this is the y-axis, this is the x-axis, and we haven't done any image manipulation in this section or in this lesson, but in future we can do that. But this is kind of a basic kind of a starter. Okay, hope you guys enjoyed the video.